It's nice to see you here. I hope we will have some good discussion afterwards. So I will be talking about using AWS as a starting point and then to proceed from there. But first, a little bit about me. I have been doing IT trainings for more than 20 or 25 years. My first professional job was working for the biggest ISP in Slovenia. Then I was part of several other bigger ISP projects. I was also on the editorial board of the computer magazine called Monitor and so on. So basically I did a lot of different projects. But in the last couple of years I'm mostly going around doing consulting and training, mostly on the containers these days. So mostly OpenShift, also some Kubernetes and so on. But I still have some of my existing customers who are still not ready for the cloud. And what I hear from them is, yes, we would really like to be in the cloud, especially from the management, but for the people it's hard to start. So I will be talking about the perspective how to start if you are not already ready for the cloud. So generally you want to be either cloud ready or cloud native. You don't want to be without cloud alone, because that's generally bad from many perspectives. So usually most of the organizations want to start at least with cloud ready. So with cloud ready, you usually have some existing stuff. You usually want to leverage cloud for some things where it's useful, where it could give you an advantage and so on, but you cannot simply scrap everything and move to the cloud native model. But for example, for the new projects, starting with the cloud native part is actually very, very recommended method. And I believe most of you should be developers, most likely know about this 12 factors model, which generally means use the same code and just configure it and run it differently. So you are not storing anything specific inside the code. Everything is done outside, externally. And this 12 factors model will basically help you become cloud native in a much, much faster way. So if you are cloud ready, as far as operations go, you have some flexibility, but not much. You cannot, for example, simply scale up. You cannot scale out and so on. So you can do only some things. Also redundancy. You can do redundancy on the local level, but it's hard to do redundancy on, let's say, more than 2 locations. Why? Usually your applications were not designed to be spread between different locations. Usually you don't have the team to do, for example, geographical failover and so on. Most likely you don't have low latency connectivity between the locations and so on. So start with cloud ready model and go from there. So before you want to be cloud ready, you need to do some essentials. Anybody knows what would be the essentials to become a cloud ready? For example, when I was doing projects for big enterprises, for example, implementing another virtualization solution and so on, what do you think, what was the biggest pain? What was the hardest thing to get from them? It was not the money, it was not the approval. What do you think, from the operational point of view? Any idea? Starts with 3 letters. DNS. DNS is still a big problem for a lot of organizations. A lot of organizations still rely on hard-coded server names, on IP addresses and so on. So, if you want to become cloud ready, usually you need to deal with these 3 segments. So first thing is network segmentation. I still see big networks where basically they have all their servers and the clients in one big network, most likely also with Wi-Fi access, bridging to that network as well. And you can imagine what happens with Windows if somebody decides to take the IP of the server. Not good. So this is just one part. Also, for example, if you want to have flexibility to later maybe move your server somewhere else, of course you need to separate the servers. And if possible, separate them also by their function. So have different networks for different use cases for those servers. And again, also separate the clients. Usually you don't want to have Wi-Fi clients and local area network clients on the same segment. Why not? Bring your own device. You can get so many tablets, so many phones and so on with various things installed and so on. So this network segmentation is extremely important because if we are ready, if we have our server separated, then one day we can decide, for example, over the weekend to actually move our server somewhere else. And if things are done properly, our users will not notice. They might even say, wow, it's running better than before. Why? Maybe we moved the servers to better hardware, maybe we got good connectivity and so on. So it's important to plan those things in advance. So if you are not ready with the network segmentation, start planning now. It's important. Then the next thing is DNS. For any serious enterprise solution, you want to have fully working DNS in both ways. So from name to IP and from IP to names. For a lot of enterprise projects, this is a requirement. So don't use IP numbers. I used to say use specific IP address for services, so you can move that service between different machines. But these days, I don't want to tell you to use IP addresses at all. Because with cloud, with containers and so on, you cannot rely on IP addresses. For example, the only reason why I'm interested in the IP address for my containers is because I want to know on which machine it is running. That would be the only reason. So if I observe some anomalies, I can check, maybe it is the issue with the host where my containers are running. So always use service names. And if possible, don't use too many names. Why? When you move things around, people usually expect that if something was once working, it will work always in the future. And you don't want that. And especially these days when you need to use certificates. Usually you don't have certificate for all the names. So your clients will have issues. So try to stick with single name. That's the best thing for you in the long run. Then the last thing, which is also often forgotten, is reliable time. Reliable time was always an issue if you had any serious single sign-on solution. For example, with Kerberos, can your time on the client can be, let's say, few hours behind the server, or maybe even worse, in front and so on. So you can basically fix a lot of issues by using reliable time. Then reliable time is also important for the certificates. And last but not least, the logs. When you have things distributed, when things are running on different machines, you need a reliable way to basically see what was happening on so many machines at once. And if your time is not correct on all of them, you will have issues, for sure. So, if you manage to do all those three things, then you're in pretty good shape on the path to be cloud ready. So, I have my network segmented, I have my DNS working, I have my time working, and so on. What would be the next way how to become more cloud ready without introducing too much changes into the network? This family of AWS solutions is old in the cloud ways. It was introduced 2 years ago, but still, I believe it is one of the best solutions to become cloud ready as soon as possible. Generally, people usually can easily start with the file gateway part. File gateway, basically all these machines, this is the software or hardware, depends on what you decide, are basically machines which are proxies for your data, mostly proxies. So file gateway is file server, so as far as clients are concerned, it is NFS server or it is SMB server, so you can connect Windows clients and so on. What would be the good use case for something like that? Why would I want to introduce another complexity? If you remember, how do I store data on the S3? I need to know the bucket, I need to have credentials and so on. But most of the users are usually used to go to some server and put files there. So this file gateway is basically your path to this. So it is sitting between your users and the Amazon network, and you're using as an ordinary file server, but basically that data is finally stored on the Amazon in the S3. And when it is there, suddenly you get some additional stuff possible. Of course, you can do backup. Of course, you can do replication. Of course, you can do, for example, archiving and so on. All this is possible. But what is even more important, you can suddenly use a lot more of AWS solutions. For example, you can do media conversion, you can do streaming, you can do all kinds of different things. So usually, you need to put your data on the S3 and then you go from there. So file gateway is basically the easiest way for your users to start using those things. Also, another good use case for file gateway is, for example, if you need to store a lot of data, you really need to store a lot of data. It's hard for your company to suddenly buy very expensive storage, or maybe it takes a long time and so on. So basically, what you can do, you can use this file gateway in proxy, cached mode, where basically your files are stored on the Amazon, and then they can go up to a lot of terabytes. And your server is basically just doing the caching for the frequently accessed data. Yes, this means that if some data is not there, it can be slow and so on, but at least you can store a lot of data, and if you don't access it a lot, it will be very cost effective. Usually people then also ask, okay, but how much does it going to cost me? What do you think? Is file gateway expensive thing? What are my... what could be problematic if I wanted to deploy file gateway? First thing, of course, I need to have this software running somewhere, so I need Hyper-V or VMware or hardware appliance. But this is not the biggest problem. For example, if I upload something to the AWS, how much does it cost for me to do it? Anybody knows? Yes, it's nothing to upload, but it costs me to store. So basically I can start with something small, and basically I'm paying as I move along. What can be a bit more expensive is basically if I then download again from the AWS. So this is the part where I need to be a little bit careful. So I'm paying for the charges when getting data back from Amazon. But if this is something that is not being used so much, and you still need to store it for a long time, this can be very, very cost-effective solution. So this file gateway is excellent solution, and very easy to start. Basically, you just download the software, you need to activate it, so you basically tie it to your Amazon account, you put it somewhere where your clients will use it, and that's it. The next one is a bit more trickier, volume gateway. Volume gateway is basically about my disk data. So with volume gateway, my volume gateway is basically iSCSI target. So I'm serving the data to my local clients. For the volume gateway, I can have two options. It can be either cached or local. Basically, it depends where is the real source of my data. So if it is cached, it means everything is being stored on the Amazon. And if it is local, everything is being stored locally and then incrementally pushed to the Amazon. Again, for most of your users, they should not notice a difference. If your network is fast, if your machine where you are running this is fast, they should not notice. But what do you get from that? Because this data is also being incrementally sent to the AWS. On the Amazon, you can get snapshots. And those snapshots can be your points for your, I don't know, some testing. They can be your points to start if you suddenly want to move to the cloud directly, or they can be even your important starting points if you want to do recovery. Potentially, what if your main location is down, if you're not able to get it up in some good amount of time and so on. So you can basically start those things on the Amazon. And if you planned it properly, if you configured your networking on the AWS properly, if you have VPN connection and so on, those things can be totally invisible to your users. So the first two are basically my favorite things for the clients to migrate or to at least start using AWS in some sensible way for them while still preserving their initial investment. And the third one is also interesting, but this is mostly for the really big customers. The tape gateway. The tape gateway, technically, again, it's just an iSCSI device which is presented to your software as the virtual tape library. Why would you want to use this tape gateway? Any idea? What is the usual problem when you are archiving on the tapes? Do you keep them somewhere close to the servers? You need to ship them somewhere, you need to be careful how they are stored and so on. You need to basically have them and so on. So tape gateway is a great solution for big customers because basically they can start backing up also to the cloud. How many copies do you usually have for your production data? 1, 0, more than that? If you're smart, yes. But usually we can be lucky if the customer knows that it's good to have at least 2. So one should be very local and one should be in the cloud. For example, I had a customer who basically said, my backup for my mail server will be running, will be stored on the cloud. And then I asked him, okay, how good is your internet connection? I believe they had less than 100 megabit per second line, and they wanted to store 2 terabytes of data. How many days would it take for them to recover from the total damage? What do you think? 1, 2, 3? So they are not able to quickly recover. So simply thinking about the cloud as the only destination is wrong. But people think, with clouds, it's so reliable, they have so many copies and so on. But what does it matter if your downtime is too big because you're not able to get your data back? So, usually, yes, use the cloud, but use it as the second or third destination, not the only one. Oops. So, I have used those appliances to store my data in the cloud. What can I do next? Technically, you can do nothing. You can just simply use things. Your data is being stored in the S3 already. So you could use, for example, AWS backup. You could use replication stuff. You could, for example, send it to Glacier and so on. So you have a lot of possibilities. But what is more important is this. You can do additional stuff with that data. So this is the important part where maybe organization was not even thinking about that part of being cloud ready. But it's very easy to start. So if you have somebody who is willing to try out new things, who is willing to do proof of concepts and so on, it's very easy once your data is in the S3, somewhere, doesn't matter where. Very, very easy. And even you can, for example, prepare servers on the EC2 and attach to that data and continue working. For example, if your local storage gateway fails, you can basically start another one in the Amazon cloud and simply point your clients there. So now you see why you want to use DNS, why you want to use abstractions and so on. So that's one way to do it. Simply continue running from Amazon everything until your main location is back again. As usual, when you use storage gateway, you need to be slightly careful. The bucket where you store the data, yes, you can connect a lot of different clients to that, but you still need to be careful. Because, for example, when you put objects inside that, what if you put folder and the file with the same name? So usually you need to be careful. So usually you want to treat those buckets more as an read-only stuff. It's usually not good to mix them too much. You can if you know what you're doing, but you need to be careful. So one way to quickly start is basically by activating another gateway on the Amazon. Or, for example, in the case of my volumes and so on, basically I could prepare servers on my EC2 and attach that data. Remember, these are the snapshots. So from the snapshot, I can create a volume, I can attach it to a server and continue using it. So, for example, if you have some extended outage, maybe it's good to start thinking about actually moving some of those things to the cloud. And if you are planning with your IP addresses and so on, then it can be very transparent to the users. Of course, you need connectivity. But connectivity, I believe, even in this country, should not be an issue anymore. Yes? No? No. Still not? Yes. For example, at home in Slovenia, I have optical connection, but my provider decided that because I don't have a business connection, 40 megabits is the top upload speed I can get. Even if I want to pay, I can get bigger download speed, but not bigger upload speed. So the only way for me on that same connection to get a bigger upload bandwidth is basically by purchasing a business subscription, and then I can get, I believe, 100 megabits or something like that. Or if I can go with their other different plans, which are very, very, very expensive. So currently, yes, I'm using the cloud for backups, but I also have my local copy. I also have my local NAS in order to start working as fast as possible. And it saved me once because I had issue with my 8 drive RAID setup. So I actually needed my backup data from the cloud once. So it's good to have more than one copy. So you had a disaster. What now? You should be planning for the disaster in advance. You know that disaster will surely happen. It's just a matter of time. You cannot simply say, I'm so lucky not to have a disaster. I have one customer which is basically paying very small amount of money because so far they did not have any serious disaster at all. But they are just lucky. They don't even know how lucky they are. But don't count on that. Most of them are not that lucky. So you need to start thinking about the disaster. You need to at least start thinking, what are you going to do? What can you do if, let's say, your servers are completely destroyed? Maybe they got crypto ransomware, maybe whatever. It could be even your local users. You could even have, I don't know, local user who is not happy with something in the company. You could have local user who does not know enough about the things and so on. So you need to be ready for the disaster. And if possible, of course, use the automation. Automation will help you test things, will help you prepare for things. Automation will save you a lot of time when this happens. How many of you are you already using automation? At least once per month if possible. Few? But why do you use it? For the application deployment or for the infrastructure deployment? None of that? So please use automation. It will help you a lot. For example, I'm also a Red Hat instructor, and I don't know if you are from this field, but for the Red Hat certified engineer for the version 8, the final exam for the engineer is the Ansible exam. So no longer you can be a Red Hat certified engineer without any knowledge of the automation. It's simply not possible. And they did it because they noticed that when companies are looking for the people, for the system administrators, automation is on the 20% number of those requests, and it is growing very, very quickly. So if you want to be competitive, start with automation. And then you need to decide what will be your next step. Do you just want to temporarily recreate the environment, or do you want to actually move everything? So if you plan ahead, if you use DNS, if you use proper network segmenting, if you have the equipment, it's very easy to do both of them. So you are prepared. But finally, of course, the cloud is great, really great. But if you are moving to the cloud for the savings reasons, then you have a wrong objective. You should go for the cloud, for the flexibility, for the new things, for the, like people before me mentioned, to be faster, not to save. Because if you want to save, at least temporarily, there are other ways how to do it. But then yes, you will lose for sure scalability, you will surely lose on the flexibility and so on. But you have a service, so you can basically check with the calculator how much you are going to pay. For example, if you store, let's say, 10 terabytes of data, and then every month you expect to fetch back at least, let's say, 5% of that. So you need to prepare about those things. Sorry, too quick. Any questions? Yes?
You talk about backups to the cloud. What
Yes.
about backups when you're already in the cloud?
What about them?
So you mentioned how expensive it is to move data to the cloud. What about
No, it's not expensive to move it.
to retrieve it? Sorry, yeah.
To retrieve it, yes, that's expensive.
Does the story change now when we talk about doing it from the cloud?
You need to be careful when you have your servers in the cloud. For example, if again you're storing stuff on S3, If you're using the public endpoints for the S3, when you are storing data there, it's free. When you're retrieving back, it's expensive. So if you want to use those AWS services inside of your virtual environment on the cloud, you need to properly configure the services, especially this S3 part, yes. Then it will be much, much cheaper for you. Generally, I also advise people to use more than single cloud, but this is, of course, not the initial step. Any other question? If you disagree with me, of course, please say it. It's good to hear different opinions and so on. Initially, I was thinking about talking about containers and so on, but considering the time limits, I decided to go with something which is easier to achieve for most of the customers. But, of course, we could also talk about containers a lot. Okay, if that's all, then thank you for your time.